Hi there. I'm Steve Maresca. I'm with Zentific, and this is Matt Fusaro. We'll be presenting together today, and we'll be bouncing off each other. And also, please feel free to jump in. It's a small group, so this can be a pleasant conversation if anybody wants to. So, what's Zentific? We are a software development firm, so we are integrators of Xen in our own products. We have been using Xen for a very long time, and I think that I can probably say that I've been active in some fashion in the community since 2007. Now, that has spanned many different interests. I'm a security guy, first and foremost, so that means I've always been looking at Xen from the perspective of a tool to help my analysis work. But as a systems integrator, Xen has provided a lot of opportunities for deploying guests, managing large fleets of virtual machines, test infrastructure, development resources, and the like. We have footprints in data centers where we service our own customers, and we use Xen exclusively. We would like to really present this talk as from the perspective of an integrator of Xen, to share our experiences and hopefully motivate those who have not actually taken that step to do so. We are among the groups of companies who have submitted patches to Xen, certainly a small player, but as we'll cover in a little bit, Xen has been an interestingly open community from the start. Very helpful for getting your feet wet as an independent developer and otherwise. We have been building a product around the Xen hypervisor, using the Xen hypervisor, and we'll get to that a little later. It's a security product in particular, has many interesting uses beyond that case. So to sum us up, we build security tools, we build support tools for observing virtual machines, and we work with developer aids. Bottom line is that we enjoy working with difficult problems, and Xen, first and foremost, helps us solve them. So today in particular, we're here to talk about Zazen, which is a security product we've been developing for some time. Zazen is the result of several years of research and development. It's built on Xen. We stand by Xen as a great hypervisor explicitly for security work. And it's fantastic support in the security community, and we'd like to offer our explicit affirmation of that. Xen provides many, many unique capabilities that make our product possible, and we'll get into that. But before we do so, we'd like to get into Xen itself, why it provides us as a software vendor what we need, and why it was most appropriate for our needs.
So one of the main reasons we chose Xen was because of the maturity of the project. Lars alluded to a lot of this in his presentation about, the myriad of companies that have a huge investment beyond Citrix. SoftLayer, Amazon Web Services, Rackspace, they heavily use Xen every day. The other integrators, the Dells and HPs of the world, their servers are certified for running Xen Server and Xen. There's integrations with storage systems from NetApp, Dell EqualLogic. I'm sure you've heard of these during your work days. And the openness of Xen was another major reason that we went with them, and their robust foundation. There's lots of small and reusable components. You can take XenStore, OpenCaml, OpenC. Sorry about that. The libxl utilities, XenTop, PyGrub. They're all small systems that can be easily separated and extendable from there. Their APIs have lent major products to be developed. Xen Server is a clear case of that. Rackspace and AWS's interfaces directly integrate with their APIs. They've been backed by the Linux Foundation, which is obviously has had such a great success for them in the past year. And a particular reason we went with them was that they focus on the hypervisor features themselves. They don't try to be a flashy interface. They don't try to be, the be-all, end-all of integration and management. They focus on very specific hypervisor performance and reliability, and that's really what we wanted to see lined up with our product as well. There are bug fix systems. We already went through that. They're very robust. They're very mature now. And they're very proactive to security responses and vulnerabilities. From my experience, any types of patches or anything like that we've had to get through, they have been reviewed and very impartially put into the project. I'll talk about our ecosystem.
Okay, so we've already touched upon the open nature of Xen, but I'd like to elaborate a little bit. There are developers from every country in Europe, every state in the United States, South America, every corner of the world, and there aren't really any boundaries that define what a Xen developer might be. You see them from security companies. That's sort of selfish to bring up, but you see them from hosting companies, you'll see them in operating system developers. These are foundational tools, and they find use in many, many, many segments of the industries. As Matt mentioned, the Xen community in general has always considered worthy enhancements from outsiders, and they're always discussed in a way which is constructive. That's not necessarily found if anyone is familiar with the Linux community, which can be famously abrasive, which is okay. It works for that world. Xen is a wonderfully nurturing environment for new developers. You don't necessarily need to understand how a subsystem, the hypervisor, behaves in order to identify a problem and then work to a solution. The bottom line is that the maintainers of each subsystem are patient educators, and if you have a question, it's extraordinarily likely that you will be warmly welcomed and received and guided through the process. Now, the reputation Xen has with the security community is a fairly outstanding one. We've alluded already in some of Lars's presentation about KubesOS and OpenXT. These are isolation systems built on top of Xen. In essence, Xen is used as a framework for running high-risk workloads in one segment of a system and low-risk workloads in another, and preventing the two from meeting in the middle. This is extremely nice because if you're working on a workstation, for example, you can perform your banking tasks in one, which is very dangerous or sensitive, and then browse YouTube or whatever you would like in another. Xen provides the facilities to make all of that possible.
And some of that's the reason why Xen was very important to us. It provided the isolation between different VMs that we needed. These next two, providing VM memory and VM CPU access, is paramount to the type of work that we do, and we'll get into what that means for us. Event delivery, we'll talk about that the next slide. And architecture agnostic. We're able to not only support Intel x86 products now, the AMD platform and the ARM platform are now also getting support, and we actually have patches being pushed very recently in the past few days for the ARM project. And also the debugging facilities, which we'll also get into.
It's worth noting that the Xen security modules up top there are going to be discussed later on by Russ, which I highly recommend taking a look. We've been involved in that in some respects over the years. It's a very worthy platform, a bit tricky to work with if you're new to it, which I know we are working to improve in the community. But it's extremely helpful if you wish to isolate one virtual machine or a group thereof from others, or at least have some guarantee that they will only do the tasks that you have designated that they shall do. Okay. So, Memory events. Why is Xen important to Zentific? This is perhaps the most important. You heard a little while ago about some work from Bitdefender, and we're operating in a very, very similar area. Memory events are a subsystem in Xen which allows you as a security entity to monitor certain behaviors of a system. If you're willing to, or if you're interested in monitoring the modification of a region of memory, the setting of a particular aspect of a CPU, these are things which you can subscribe to as events and then listen for and act upon. Very important from a security standpoint to be able to prevent or authorize an action to take place. And this is a mechanism which enables it. These are accessible via very low-level Xen APIs, which are by themselves perfectly fine. But the last item I'm mentioning here is libvmi. This is a virtual machine introspection layer. It's a library developed by a gentleman named Brian Payne, formerly of Georgia Tech University and currently at Nebula, which is another cloud vendor. It's a wrapper around a variety of APIs, KVM included, but foremost in Xen, the libxc library. These are the mechanisms which we use to perform some of the tasks that are crucial to us. The important thing to know about memory events is that as an observer of an environment which we wish to secure, it's important to operate efficiently. Without the ability to be notified of actionable events, we would have to be constantly spinning CPU, observing the values of memory regions. This is expensive, and it's also impactful to general performance. To receive events as they occur, before they occur, we have the ability to interpose our desires, audit what's occurring, and take many beneficial gains from a performance standpoint. It's worth mentioning that the diagram I have here is effectively how every driver works in the paravirtualized Xen world. It's just a representation of a buffer, which is constantly rotating. Every piece of data that gets placed there can be received by a listener, and the side that's publishing just keeps adding stuff to the ring so they can be consumed efficiently.
So we kind of summarized the things we just talked about and compared that to the other hypervisors that we have available. And Xen kind of stands out as the winner here for us. The low-level API access for doing things like CPU, memory events, actually getting to the hypervisor itself to control it. Xen has that capability. It is definitely in things like Hyper-V, VMware, and KVM. The facilities are much different, and VMware, like with most things, you have to pay to play. So it wasn't really something we wanted to get into immediately to start making the product. In KVM, you have to do some patches to QEMU to actually get into the system we need to talk to. Debugger facilities are kind of across the board. Documentation of the APIs, and actually usable APIs as well. Some of the APIs, especially in Hyper-V, are documented to do this type of work, but there's not actually really any usable libraries out there or an API to really get to dive into and actually get going.
Auto-generated documentation is great, but it doesn't mean it's useful.
Another major reason, and Russell will allude to this, I'm sure, is isolation and hypercall policies. So we can actually kind of make ACLs based on what we want our security domain to actually be doing to other systems, and create a separation between higher security, lower security, and let the user decide what types of actions they want to happen on their VMs. So what does this mean for the users? This sounds very developer, a lot of developer talk here. Security can be efficient, and that's not something that you can always say. And getting fringe benefits from security is not something you'll always be able to say and get away with here, and I think that we can say that.
So, before we actually talk about what we've built and why these foundational features are important, I want to talk about what security means in a virtualized world. In general, in every security context, whether it be virtual machines, purely physical security in a room with a lock, you're always trading protection for convenience. If you have a home and you have a deadbolt on the door, you by definition have made it more difficult to enter that building. Now, it's a simplistic example, but it slows you down. The same thing is true in the real world. If you have to change your password because of your corporate policy every 180 days, not only is it frustrating and annoying, it's probably going to produce some questionable behavior. Every password has a new number tacked on the end. You know, these are things which are interesting conundrums because the goal is increased protection, but there are certain side effects. In addition, protection mechanisms are themselves not infallible. They're not invulnerable. They fail, and we know that all the time. Cars are stolen, homes are burglarized, servers are hacked. These are truths that we know to be accurate and real. I'm sure many of us have experienced one in some flavor or another. But the point is that we have to make our security decisions intelligently. Especially in the software world, security occurs, and any protection occurs at the extreme performance degradation that you can see in firewalls, network appliances. It's a guarantee that if you enable certain deep inspections of data, you've reduced your overall throughput, sometimes by half or more. The same thing is true in an operating system. The application of antivirus, the application of malware scanning, these things reduce system performance. So often, they're disabled. And the crux of this is that because we share infrastructure in a virtualized environment, every application of additional protection means that your overall performance goes down. And in many virtual environments, security is treated as an wholly optional endeavor. There are fleets of virtual machines that desperately require some sort of virus protection that simply have none. And it's a real problem. So, the threat landscape within a virtual machine.
So, what we're seeing now is some dangerous adjacencies. The malware and the thing that's protecting you against the malware are in the same machine. They're part of the same attack surfaces, and in many ways it's relying on information that it's trying to get from the thing it's protecting. We have wide open doors in VMs because we're choosing not to employ security for performance reasons, for management reasons, and we're seeing more and more attacks with very high degrees of sophistication. You know, you've seen the Home Depot and Target attacks that have happened recently. Return-oriented programming, if you're familiar with that. There's even situations where people are using good code that you have actually put into the system and trust to perform malicious attacks. And this is putting the defenders in a very bad position. Signatures just don't work anymore. They are good to get the things that have either already happened or have already been analyzed, but we need more behavioral types of scanning. And looking at the system and deciding, is it abiding by the rules that it should be from the hardware perspective, from the software perspective? Is an operating system doing what it's supposed to do?
The fundamental takeaway is that the sharing of resources in a virtualized environment, the adjacent nature of one guest with another, means that everything impacts everything else. And you could apply in-guest antivirus. Many people manage their infrastructure very normally. You have Microsoft System Center endpoint protection, semantic, McAfee, whatever your enterprise or small business or home user likes to use. They're all applicable in a virtual environment. The trouble is that at scale, these things often perform scanning in a less than advantageous schedule. If you scan at 3 o'clock in the morning across your entire enterprise, you've pegged CPU in every single rack, in every single VM, in every data center. Now, most people don't apply a silly scanning schedule of that variety, but it requires careful tuning. And it doesn't work at scale. It reduces density. There's cost to that. You need more hardware to achieve the target number of virtual machines. These are big problems. The bottom line is that traditional approaches are not built for virtualization. They're built for systems which have dedicated purposes and can tolerate some performance loss. Now, one thing that has been on the market for some time from a vendor that begins with V is vShield. It's been around a long time. In 2008, it was something called VM Safe. The overall concept is that VMware provides some access to their own internals so that vendors, like antivirus vendors, can plug in and take advantage of some of the notifications that they have available. The trouble is that the model they've built is A, VMware only. That's great, but it's also pay to play. But you have to double dip because you need the other vendor support also. It has a heavy focus on file scanning, which is great, but you could do that at the storage layer too. You could do that in a very traditional manner. And furthermore, it requires an in-guest agent to do some of its work. That's a problem because anything inside of a guest is itself vulnerable to the same things that are attacking that guest, which is where we are coming in.
So we built Zazen. Zazen relies on the memory access and CPU access from outside of the guests. And because of that, we don't need agents inside the actual VM to scan memory regions or look at the CPU. We integrate with off-the-shelf hypervisors. Mainly, we've been focusing on Xen, but there's much promise for other ones. And we really built this with cloud providers and people using hypervisors in mind. That was the first goal of the project. This unique position that we're in for our scanning line of sight, it gives us a sense of stealth because we're not inside of that VM. We are separated away from the VM. We're protected from the things going on inside of a possibly compromised system. We're using some of the latest things from Xen. I think maybe from the 4.3 and up is really what we've been looking at, and the things that have been developed since then have been helping us out quite a bit. So, thanks for the marketing. What does that really mean, and what's it look like? Really, what it is we developed a system based on a grant from the Cyber Fast Track from the government, from the DARPA, and that was about a year-long project, or 6 months to a year or so. And we started looking at this and saying, hey, there's a great opportunity to look at the RAM and vCPUs of these VMs and actually say, this VM is not operating properly. It looks like there's a rootkit installed. Something's hooking a function. So what we do is we actually have created a separate VM. In that VM, we have policies, we have scanning logic that looks at the VMs that you want to scan and can determine whether or not it's doing something it should or shouldn't be doing.
It's important to note that security VM that we've called out on the leftmost blue block there is protected explicitly with Xen security modules. Right. It's a crucial aspect to the product we're building because this VM has access to the memory of all of the others. It needs to be secured. So we're using something called virtual machine introspection, and I want to touch upon that. Has anyone heard of the term? You two don't count. Okay, so who's used a debugger? All right. Think of introspection from the perspective of your use of debugger against the process. When we're talking about hypervisors, which have debugging facilities, we're not really looking at a process. We're viewing the entire virtual machine in all of its physical memory. That's a problem because normally operating systems are participatory in debugging. When you say, please attach to Internet Explorer because it's crashing and I want to figure out why, Windows actually says, oh, all right, here's all of its memory and hands it to you in a nice parcel. Virtual machine introspection is the act of recreating all of that state which is normally provided by an operating system. And you really should think of it as debugging from outside of a virtual machine, because from that perspective, this begins to make sense. We titled the presentation On the Outside Looking In, because that's precisely what this is. We are reading memory from outside of that memory region. There are some challenges there, because there's no guarantee that an address in that range is directly accessible to you. You need to know where certain addresses are pointing. That's actually quite a complicated endeavor, especially dealing with program level logic, operating system level logic, and then hypervisor logic. So virtual machine introspection is simply the act of unpeeling that particular onion.
So like we said, it's observing a virtual machine from another perspective. That could either be the control domain, DOM0, or you can be in another user VM, and then we manage the access to the other VMs using XSM. The main operation to get to that memory is performing that virtual to physical address translation, deciding, what address we're looking at in what VM, and what's the offset, how are we actually getting to that address.
In what process?
Right.
What's the content?
We can receive events using introspection, so we can basically register for what we want to know about. Do I want to know if we're writing or executing a certain page? Do I want to know if the value of our CPU register changed? Let me know about it.
This is crucial because some of the derived benefits provide knowledge about which tasks are executing when. You can tell, for example, from memory events around certain CPU registers when a new process has launched. This is important because processes are hidden when a rootkit is at play. And you really need to know where it is, when it started, when it ended, and what it was doing. These things are crucial for inferring that behavior.
And like we've said, the libVMI project was really the cornerstone of what we built this on. And this kind of goes back to the days of Xenâ access. And I'll let you.
Yeah. So in 2008, there was a VM introspection project. It didn't go anywhere in the Xen community necessarily, but it's simply because I think the research hadn't quite advanced enough to bring us where we are today. If we fast forward a number of years, in 2014, we've seen a progression from Xen Access, which was a project developed originally by Brian Payne that I mentioned earlier. It became libVMI by the same authors, which we are now developing in addition. And then the progression allows for a product like Zazen. Now, this overall path has taken a long time because it's a very complex one. You have to recreate that notion of VM state. And that means that the complexity is an order of magnitude greater than typical debugging. That struggle is often called the semantic gap in academic circles. It's just a fancy way of describing the lack of information when you need to rebuild it. But the progression over time has really made Zazen a definitive outgrowth of some of the early Xen work in this community in particular. No other hypervisor has the research community behind it, the security community behind it, and these interesting use cases.
So we've already talked about how we're in an unimpeded position because we're looking at VMs from the outside. Zazen kind of is the detective that's sitting behind the two-way mirror. One of the things that we wanted to do with Xen was we didn't want to have a ton of patches put in by the user. We didn't want to have all these complicated builds to do it. So we stayed very true to what Xen is. When you download Xen today, you can use a lot of what we have. I think the only changes, you don't even have to use this really, is the XSM modules. That's really the only thing that's an optional build at the moment.
It's important to say that as a vendor using Xen, we want people to use supported Xen.
Right.
There are some vendors in existence who have deployed their own packaged fork. And as Lars talked about earlier with the ARM work from Samsung, that's a problem. It ultimately fragments your community and provides very difficult integration work. The fact that Xen, as it stands, is capable of this type of work is a fantastic, fantastic thing.
So let's talk about some of the capabilities that the introspection layers of Xen has given us. We're able to not have to deploy an agent inside the guest to do the security operations we need to do.
This is a fundamental difference from any antivirus you run inside your operating system. It either requires a kernel module, a driver, some sort of scanning tool. These things simply do not run inside your operating system. There's a huge benefit to this.
We can interact with processes, so we can kill a process if we need to. We'll know when they're launching, when they're closing. We can start a process if we need to. There's a lot of DLP applications and redaction applications to this. Because we know what's in memory, if you're interested in certain files being opened or certain algorithms that may bring in data that you may not want ever leaving that system or even be in memory, you can write to that memory. Let's say a social security number is in there. Let's zero it out. Or if there's some string that you just don't want in there, you could we can alert people, we can freeze the VM. And kind of the obvious security application here of detecting rootkits, modifications to kernel data structures, important things you care about, like the operations that a file is allowed to have, repairing hooks. And some interesting things that we've come across is performance analysis and looking at metrics of a VM. There's a lot of things that are interesting inside of the VM that you may not always have access to. You may be looking at a customer's machine for support, and they want to know why their performance is bad. Well, you may not necessarily be able to get into that VM, but we could let you know, what processes are running. Standard performance counters that you'd want.
It's important to mention. It's important to mention that sometimes, especially in a customer context, there's an expectation that that virtual machine is private. Unless there's an agreement with that customer to run some sort of reporting agent, which is a rare thing in many providers' environments, it's a black box. And having an awareness from a provider standpoint to assess customer behavior in a non-invasive way is a fairly attractive notion. Not only that, but if you have an application which merely does not report a piece of data, you can get at it this way, as long as you know where to look.
This is very important for anyone who's ever done any type of response, a threat response. So if you've already been compromised, you need to know what it is that happened. There's a wealth of knowledge that we can get out of this system that you wouldn't normally see, because we're actually looking at a machine while it's running. We have a timeline of what process launched, when did it launch, what types of files did it access, network sockets were open, things like that.
It's often after the fact that you realize a compromise has occurred. Right. So if, for whatever reason, the cat and mouse game was lost on a particular day, it's a guarantee in the world of security, so you want to hedge your bets. The absorption of the data obtained through these mechanisms is helpful for going back in time to figure out precisely what did occur so that you can stop it in the future.
And because we have all this information available to us, it's interesting to think about what else you could do with that. Putting that out to other security systems. If we have a VM that's opening sockets that we don't expect, let's let the firewall know about it. And anyone who's interested in malware analysis or even just basic program debugging, looking at a live system that doesn't have an actual debugger attached to the program, it's interesting to see what types of things will happen. You can do a stepwise analysis of something that's running, stop the program, start it again.
This is an aspect which is particularly interesting to the security research community. A variety of vendors have already built this type of infrastructure already using in-house equipment, which is all well and good, but it's brittle. And keeping that up to date is a struggle. Having it available through a completely standardized hypervisor is a fantastic benefit. And as I hinted earlier, if you want access to certain data inside of applications, that implies a certain awareness of the application structure. One of the most crucial things that we've been able to do is, in addition to rebuilding the operating system state, we've actually been able to dive into every single running application. So that means that we have an awareness of what each application is doing. That boundary is not often passed in a security monitoring standpoint. So it's very possible that a vulnerable application that's under attack will be observed long before anyone actually knows that there's a bug. So there's a lot of troubleshooting, bug analysis, vulnerability reporting potential here. And that depth and breadth of view is what makes this a powerful platform.
What really drives a lot of the information that we're getting out of the systems is how we were able to build a rule engine around it. It's good to know that something happened, but what do you do about it? And humans constantly interacting with the system that's being compromised is slow and inefficient. So you need some way to act on those things. And this is kind of our answer to that. And really this kind of shows you what Xen allows us to do, is to build a system that's as robust as having a rule engine, kind of almost like a firewall for your own VMs. You could think of it like that. Certainly we're looking at more than just network traffic here. Now you can start creating rules on what do you do when certain processes launch, what do you do when certain information is discovered inside of your memory. Certain OS states can trigger certain actions.
So as Matt mentioned, it's a firewall concept for VM behavior or program behavior. That means we can operate upon VMs, groups of VMs, users that are executing certain processes. Any event that you deem interesting can be actionable. And we have a set of default actions in our system that can be taken, but it's an extensible system too. You can do what you wish with the event at the time the event occurs. Some of the examples that are worthwhile to mention are terminating processes, suspending the VM, quarantining virtual machines, taking a forensic image for analysis, sending an email in a really simplistic fashion that a certain process stopped. You can think of this as in the analog of this tool like Zabbix or Xenâ, or any system monitoring tool. The extension in that vein is a very simplistic one, but a very productive one, because again, there's no agent, zero footprint. That's unusual to say.
So we'll just run through a couple of use cases so you guys get an idea of where this would be applicable. Hosting companies and anyone running their own private clouds, this is an easy one. You need to secure VMs, and you'll need to be able to support the infrastructure that you're running. Misconfiguration is one of the biggest reasons that there's compromises these days. So being able to tell whether there's something wrong with an image that gets deployed from your provisioning system can definitely be useful. If you're doing risk assessment or mitigation, we can determine the patch levels of the VM, application inventories, automatically quarantining certain VMs for bad actions, and alerting and monitoring. You want to know if something has happened to your VM.
So troubleshooting, I've alluded to that. I talked about introspection as a debugging task. It's absolutely true. You don't need to be protecting your virtual machine to care about what it's doing. You can extract logs. You can take a screenshot. These are facilities that are available to us in other forms, but having it all together in one package is an interesting change. The ability to say what open ports or active connections exist within a virtual machine is a curious one. In a security event, you may not have that luxury. Your tools within the operating system, which you normally rely upon heavily to actually assess that stuff, might be compromised. Rootkits do this all the time. There's no guarantee that running a port scan from outside of the virtual machine will reveal that stuff. Being able to look at what the operating system truly believes to be its current state, true or otherwise, is a useful aspect to this. And simply state preservation on crash, application internals, being able to recover this stuff after the fact. And absolutely the vein of security, which we are harping on over and over again. So future work for us include Hyper-V support, VMware support. These things are similar features. We started in Xen. Xen's our comfort zone. We like Xen. It's nevertheless applicable elsewhere. We have a suite of tools that are soon to come out. These will include simple things like process explorers for virtual machines, simplistic report of what a virtual machine is configured to be using. These are typically things which you have to infer, set at provisioning time, collect with an agent, things of that sort. Without that need, provisioning is simpler, management is simpler, there are less moving parts. And that's really where we're headed.
So just a really quick demo, just so you guys can get an idea of what it actually looks like. Always helps to put this in terms of. So basically what we're going to do here is just kind of show you a couple of examples of how this actually works. So in this situation, we're kind of injecting a process here where we can actually start the command line and just print some stuff out. I think we'll do that one more time here. So what this is actually doing is talking to that virtual machine running on Xen right now, injecting the process. I think it pulls it from the disk of that VM.
Yes. These are already processes which are resident. So calculator, for example. These are simplistic examples, but we're injecting processes in live virtual machines safely. This is an under the hood view, certainly, but it's useful to see what the virtual machine is doing at that time.
This is also a good example of it. It's not something that's slow either. The internals of Xen have made this extremely quick and very performant for us. This is a DLP example. So we've got just a couple of files over here. We're tracking the file system, what's being opened. We have a couple of files there. One's a benign one, one's one that we wouldn't want anyone opening. If we open the benign one, it lets it go. There's no problems with it. And we'll see once we open the one we don't want anyone actually getting any access to. It alerts us, we know where it is, what was done, and the VM is currently suspended, so they cannot do anything to the VM right now.
In a more typical data loss prevention suite, that would be, I'm sorry, denied. But
right.
We're launching programs already. It's easy to think of this as, oh, pop up a message, I'm sorry. The same thing is true in other systems, but again, it requires an agent. Enforcing these policies from a holistic top-level view means everything's more consistent, it's more reliable, and safer. And we'd just like to thank the Xen project, of course, for having us here, Linux Foundation as well, Brian Payne, whose work has been foundational for us, and the rest of our team. Hopefully, we are actually in time. Okay, close enough. Thank you. If you would like to ask any questions, we'll be back here.